Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra, the Math 8 edition. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 5.1 on solving systems of linear equations by graphing. Hey, we know what graphing is. We know it. We love it. But what's a system of linear equations? We know what linear equations are. They create lines. What's a system of equations? Hey, we're ready to answer that question right now. Let's go. So we have a couple of vocabulary terms that we have to talk about. First of all, the aforementioned system of linear equations. It's a set of two or more linear equations in the same variables. Here's an example. They both have y and x in them. They can be in slope-intercept form like this. They can be in any form. It's just two of them. Now, a solution to the system of linear equations is an ordered pair that is a solution to each equation in the system. In our case, to both equations, because we're only going to be doing two equations. When you get into more advanced math, you can be doing more equations in a system. But in this case, we want a solution that fits both equations. All right. Now, the nice part about this, of course, is when we graph each of these equations, the solution is the point of intersection of the graphs of the equations. It's the point that's on both lines, right? This point is on both lines. And if it's on both lines, that means it's the solution to both equations. This point is on both lines. Okay, so let's take a look at an example here. Actually, our steps. Number one, graph each equation in the same coordinate plane. We know how to graph. We've been spending a lot of time on that. Number two, estimate the point of intersection. Well, we need to do neat work, because if we're going to try to read the graph back for some points, for a point, we need to do neat work, which means use graph paper and use a ruler. Step 3, we're going to take that point of intersection and we're going to substitute it for x and y in each of the two equations in the original system, just to check the answer, just to make sure. Because solving by graphing is not a real accurate way to do it. Like I said, it says estimate the point. But we have to learn how to do this anyway. So let's just go ahead and do it. Then we'll get into easier ways to solve systems in the rest of the chapter. Okay, so the first example here, we're going to solve this system by graphing y equals 2x plus 5 and y equals negative 4 minus 1. We know how to graph these things. Y equals 2x plus 5. My y-intercept is 5. My slope is 2. I'm going to go up 2 over 1. I'm going to go down 2, negative 2 vertically, negative 1 horizontally. But just to spread those out a little bit, the further spread apart they are, the more accurate my graph is going to be. Okay, so there is the first graph. Let me see if I can. Guess it's not going to move for me. That's okay. Y equals negative 4x plus 1, minus 1, negative 1, and a slope of negative 4. So 1, 2, 3, 4, negative 4 over positive 1. Okay, so this graph will look like this. All right, so I've graphed each of these now. I'm going to look for my point of intersection, and my point of intersection looks to be right here at negative 1, 3. So that's going to be my solution. This is the solution. But let's check those things to make sure that they solve both of these. This is what we're trying to find here. So y is 3. So I'm going to do the first one here first. So 3 equals 2 times negative 1 plus 5. 2 times negative 1 is negative 2. And negative 2 plus 5 is 3. All right, so that works. What about the second equation? 3 equals negative 4 times negative 1 minus 1. All right, so there's my y, 3. This negative 1 is the parentheses here. Is that negative 1? Negative 4 times negative 1 is positive 4. And then 4 minus 1 is also 3. So that's a true statement. So that works too. So this is our solution. Pretty easy, right? Okay, let's see what's next. Here's another example. Now, in this case, this is not a system. This is a kind of equation that we were playing with, that we were working on solving earlier in the school year. And this is an equation that has a variable on both sides of the equation. So we have x over here and x over here. This is the type of equation where you could have like no solution or infinitely many solutions, those types of things. But what we're going to do here is we're going to rewrite, since they're equal to each other, we're going to set them both equal to y. We're going to create a system. So y equals x minus 2. That's the first, that's the left half. And then y equals negative 1/2 x plus 1. That's the second half. All right, so basically we've taken this equation and turned it into a system. And we're going to graph this now. So y equals x minus 2. My y-intercept is negative 2. My slope is 1. So I'm going to keep going up that way. And that's going to get me, it's going to get me this graph. And then y equals negative 1/2 x plus 1. My y-intercept is at 1. My slope is negative 1/2, so negative 1 over positive 2. Okay, so right there I can see what my point of intersection is. Let me go ahead and do the rest of the graph here. Okay, so there's that line. And I can see my point of intersection here is at 2, 0. X is 2, y is 0. All right, and just to prove that this works, I'll do the checking of the first one here. 0 equals 2 minus 2. 0 equals 2. I'm sorry. 2 minus 2 is 0. So this looks good. And then I'll check the second one over here. 0 equals negative 1/2 times 2 plus 1. All right, so this is my y is 0, my x is 2. Negative 1/2 times 2 is negative 1. And negative 1 plus 1 is also 0. So this checks out as well. All right, so the solution to this equation, this goes back to the original equation. That's actually rewrote it here. The solution to the original equation, the solution is 2. Actually, I'm sorry, it's not 2, 0. The solution is x equals 2. All right, because there's no y in the original equation. There's only an x, and we put the y in here for the purposes of creating a system. But we're only really solving for x. X equals 2. All right, that's what I have for you in the beginning of chapter 5. This looks like it's going to be a lot of fun. I'll see you in class, and have a great rest of your day. Bye-bye.